Hello, this is Mr. Kong. I'm now going to go through the 2020 chemistry practical. So you can refer to your marked assignment. And I think as we go along, do look through the various things, the various things to take note of. Now, the first question will be the titration question. And what is important here is the various headings of your table. Okay, you need to know how to first draw the titration table using your pencil as well as a ruler, and then the various headings like the final reading, the initial reading, the placement has to be in this particular order for clarity and consistency. In addition, the third row is called the volume of P. So I think the common mistake is that students write final volume, initial volume, instead of final reading and initial reading. So these words must be used correctly. Now, another thing to take note of will be the decimal places. Now, for all your values in the table, they should be written to 2 decimal places. So that is something that you need to take note of. How we mark the table or your results will be to give you to look through the headings of the table, and that will be usually worth a mark. Then the decimal places, if all your values are correct to 2 decimal places, you are also given the mark. The concordance will be based on the values that you have chosen, the ones with the tick. If they are within 0.20 plus minus 0.20 of each other, you'll also be given 1 mark. So these 3 marks will be something that you can rather easily get as long as you have your headings correct, the decimal places correct, as well as choosing the volumes that are close to each other, okay, plus minus 0.20 cm cubed. Then the other 2 marks will be slightly harder to get, which will be the accuracy marks. And these 2 marks will be based on the value that the subject supervisor has obtained. So the teacher will be in the prep room performing the exact same experiment. And if let's say your value happens to be very similar to the subject supervisor's value, then you'll be given 2 marks. Otherwise, within the next broader range, you'll be given 1 mark. If you're outside the range, you'll be awarded no marks. Okay, so the minimum that you can get is really 3 out of 5 marks. So make sure you get at least these 3 marks. Now, the second part will be calculation. Okay, so your calculation has to include clear working as stated in your question. And this is just your usual calculation of the average volume. And again, your answer should be correct to 2 decimal places. Now, for the next portion here, this is where a lot of the calculations come in. Now, this piece of information is repeated at the start of this question. You are reminded again of the concentration of sodium hydroxide. And I would like to also highlight the equation that was given, because in your question, the statement of the question did mention the equation for the reaction, which is this one that we are referring to here. So you use these 2 things to calculate the number of moles of the acid in 25 cm cube of Q. Now remember, this 25 cm cube is the one that you use your pipette to sieve out. So the calculation continues, you use your previous value, which is the 18.30 cm cube, use it to calculate the number of moles of P, which is your sodium hydroxide. Then, based on the mole ratio, which is 1:1, you realize that the number of moles of the 25 cm cube of Q will be exactly the same, okay, which is 0.00366. So that this will be the answer, okay, for B part 1. Now, the greatest challenge will be the next part, which is B part 2. So with this value that you've calculated, you are told that at the start of this question, you are told that your Q contains sulfuric acid. Okay, and then blah, 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 you have your sample of 100 cm cube of the cleaning product, which was, added, you had your deionized water added until it is 1 dm cube. So the question requires you to find the concentration of the sulfuric acid in the cleaning product. So we have to do this in two steps. The first step is to calculate the concentration in 1 dm cube, okay, which is done in this manner here. And then remember that your 1 dm cube of Q contains the 100 cm cube of the cleaning product. So that means to find the concentration of the cleaning product, you need to do a second calculation, which is basically 1000 cm cube divided by 100 cm cube multiplied by the previous concentration. That will give you a value of 1.46 mole per dm cube. So this is your answer, all right? Now, the planning question, okay, your task is, the aim of this experiment is to determine the MR of your sulfuric acid, and the procedure will be a series of steps. Now, I need you to always read the question, and in this question, you are already told that there is some kind of a gas that is going to be involved, and you're also told that the gas collection should be done using the displacement of water method. So your your procedure basically has to include the apparatus that you will use, the kind of measurements that you will take, as well as the explanation of how you use your results to determine the MR of this substance, okay? So first step, okay, I'm deciding to use a particular mass, in this case, 1 gram of the HA, which is going to be the limiting reactant here. And then, okay, I'm going to add my sodium carbonate in excess, because based on the equation, the reaction that was provided, you know that this sulfuric acid reacts with your sodium carbonate to produce carbon dioxide, and you want to use an excess of this sodium carbonate to ensure that all of the sulfuric acid, which is the limiting reactant, all of the sulfuric acid would have reacted. And then you need to collect the volume of carbon dioxide. Now this has to be collected using the displacement of water method as specified in the question. Now the fourth step, you calculate the number of moles of carbon dioxide. So based on the volume, you take the particular volume divided by 24 dm cube. Remember, okay, that 1 mole of gas occupies a volume of 24 dm cube. So this is your mole concept, one of the three triangles. Now, step number 5. Remember the equation that was given, all right? So from the equation, you realize the ratio is 1 mole of CO2 to 2 moles of HA. Therefore, you use this mole ratio to calculate the number of moles of HA. And now, why we calculate number of moles of HA is so that we can use it to calculate the MR. Now, remember, I started off the whole experiment using 1 gram of HA. So I use 1 gram because I want to do this particular conversion. Now, since number of moles is mass divided by MR, okay, to find MR, I just take mass divided by number of moles. So my mass is 1 gram, as stated in step 1 of my procedure, and the number of moles of HA was calculated in step 5. So this will allow me to find the MR of HA rather easily. Okay, part 2. So they are asking you about, why the calculated value of will be different. So you need to be, you cannot be vague by just saying that it will be different, because the question already says it will be different. So there's no point in restating the question. Now, neither should you say that because of inaccurate results, because what has caused the inaccuracy? What exactly has given rise to this inaccuracy? And this is something that you need to address in your answer. So what happens is that your value, okay, will be higher. And the reason for the higher value of MR is because the actual volume of your CO2 is less than the theoretical value, which resulted in your lower calculated number of moles. All right, because your carbon dioxide is soluble, and therefore your actual volume is, some of it has already dissolved in your water, therefore it is less than your theoretical value. So explain your answer and do it in a clear, simply organized manner. I think that will be the best and the most important thing. And for the last part here, you have to use the guess range, all right? I think most of you are able to do this, but if your procedure, you forgot that you are supposed to use displacement of water, then you would have no other way. You will probably think of some other weird method. So read the question carefully because they're trying to give you a backdoor, right? So this is really bonus marks here. And the reason for using a gas range rather than the other methods is because none of your carbon dioxide will be dissolved in the water, all right? Okay, number 2 is the qualitative analysis question. And remember the kind of substance that you're given. There are 2 test tubes, one of R, one of S, and you are going to perform a series of tests on both R as well as S. So for this kind of a question, there is always that sentence, that statement over there asking you to test and identify the gases evolved. Therefore, you have to really identify the gases because it is part of the requirement of this particular task. Now for test 1, it's pretty straightforward. So write down the observations as they are. You refer to the notes that have also been printed for you. The notes are always provided for you in your practical exam. So just write down what you have observed and indicate, in this case, because there is a gas given off, therefore you need to identify the gas. The second test is another cations test. And in this case, with your aqueous ammonia, what you're looking out for is whether it is soluble in excess. So if it is soluble in excess, you indicate that it is soluble, and therefore it gives a deep blue solution. Now, many of you have wrong phrasing, such as light blue precipitate turn into deep blue solid or deep blue precipitate. And some of you didn't even mention that there is a light blue precipitate form. So all these parts are necessary points, and therefore you have to include them in their entirety, okay, in the whole thing. Now, test 3 with your aqueous sodium hydroxide is yet another cations test. So in this case, your light blue precipitate is soluble, okay? It is insoluble. Now, test 4, your sulfate test with your barium nitrate solution. Same thing, because this is a sulfate test, there is no need to test whether it is soluble in excess or not. Just write white precipitate seen if there is a white precipitate, or if there is no precipitate, write no precipitate seen, no PPT seen. Okay, no need to write whether it is soluble in excess or not, because solubility test is only for cations, not for anions. Okay, test number 5, your chloride test. Same thing. If you see a precipitate, just indicate it there. No need to say whether it is soluble or not. All right. Okay, for part B, the compound that is present in both R and S is none other than copper 2 sulfate. Now, the reason for this is because of the copper 2 ions that is present in test 2. And you also can mention that the sulfate ions are also present from the positive test result in test 4. And the other compound, now remember they mentioned that both compounds in R are soluble. So the other compound must be soluble as well. And it can either be one of these 3 answers: sodium carbonate, potassium carbonate, or ammonium carbonate. And the reason is because there must be carbonate ions since CO2 is produced. And they also mentioned about how it is a soluble substance. Therefore, you can only have sodium, potassium, and ammonium as your cations. So any one of the 3 carbonates mentioned will be accepted. And finally, the last part here in substance S, the other anion is none other than chloride. ion because there is a white precipitate in test 5. Okay, for question 3, it is a little bit like the alternative to practical kind of a question. So first part, they're asking you why. Okay, why is there a loss in mass as your reaction progresses? And this is really due to the hydrogen gas that is escaping from the flask. And the second one, they ask you to fill in the column for experiment 2. And therefore, you have to be careful and look at how experiment 1 and 3 are done, and follow the pattern. So in this case, all the values are in milligrams mg, and do take note, of how the values are actually calculated in experiment 1 and 3, and then use the same method to calculate the values in experiment 2. I will not be showing the graph. I think most of you can do the graph very well. For part 2, now you are asked to focus on experiment 1. So the common mistake is that students have used the results for experiment 2 or experiment 3. Therefore, my advice is read the question very, very carefully. So in this case, the average rate will therefore be 39 divided by 7. So you use your graph for experiment 1. You draw the usual dotted lines to get the values, and then you have your value of 5.57. They also did require you to give units for your answer. So the units mg/minute will be worth a mark as well. And then in part D, you have your conclusion of the student saying that experiment 3 had finished. So refer to experiment 3 and not 1 or 2, and therefore the best explanation is that there was no more loss in mass during the last few minutes of experiment 3. So be concise in your answer, go to the point, and also be clear and be vigilant, all right, to refer to the correct experiment. So that will conclude the whole experiment for the 2020 practical. I hope that this has benefited you. See you next time.